On the list of things that I enjoy, statistics comes right after finding spiders in my room and listening to my younger brother sing in the shower. In other words, it's not one of my favorite things. So at first, when I learned about this final project in my statistics class, I wasn't all that psyched. It meant that I'd have to find a way to apply statistics to everyday life. Luckily, the project didn't turn out as bad as I was anticipating. The first step was deciding what I wanted to explore with my project. I was told it could be about literally anything. I considered some of my different interests, fishing around for ideas before ultimately landing on a question inspired, in part, by the AP Psychology class I took last year. The week our project proposal was due, it was raining non-stop in my town. Absent-mindedly, I wondered if people actually pay attention to how often it rains. Then bam, just like that, I had my project. I decided to explore the following question. Do people perceive rain differently based on their opinions of the rain? So basically, does bias affect perception? At the beginning of my project, I hypothesized, with a typically adolescent worldview, rather cynically that we perceive more negativity in our lives. So I thought that if you don't like the rain, you would probably notice it more, and if you do enjoy the rain, you're less likely to notice it. Now that I knew what I wanted to test, I had to collect data. I created a survey at my high school composed of 2 questions. Do you like the rain? And how many days do you think it has rained in the past month? I later compared the number of days people guessed to their preference for rain to see if there was a correlation. I posted this survey to the Google Classroom pages for all of the different grades at my high school. Within each grade, I assigned each homeroom a number. Then I used a table of random digits to select 2 homerooms from each grade level. These homerooms were then instructed to complete the survey. All these steps helped ensure that the data wasn't influenced by any other factors. Maybe all of the freshmen hate the rain, or maybe all of my friends love the rain. So by randomizing the sample, I avoid biases. Once I had the data, I began to analyze it. I organized my data into a 2-way table that displayed how many people responded in every possible way. For example, 2 people guessed it rained 4 to 6 days and did not like the rain. 15 people liked the rain and guessed 10 to 12 days. 10 people had no preference and guessed 7 to 10 days. I decided to use a chi-squared test for independence to analyze the data. This test is used to calculate whether there is a relationship between 2 variables, in this case preference for rain and how many days you guess it has rained. To start the process of using the chi-squared test, I had to make my official hypotheses. My null hypothesis was that there was no relationship between preference and perception. This null hypothesis is meant to be sort of like a default. The alternate hypothesis I used was that there was a relationship between perception and preference. After I had these defined, I had to check the conditions. In order to use the chi-square test for independence, data must be random, the number of individuals in the sample must be less than 1/10 of the population, and the expected values for each category, which is in this case represented by each box in the 2-way table, must be at least 5. The first 2 conditions were met, as my data was collected from random samples, and as I had 98 survey responses, and my school population is around 1,000. But the third condition was unfortunately not met, even when I combined categories to make larger expected values. I calculated expected values by multiplying row totals by column totals and dividing by the total number of responses. The expected values are the values you would expect to find for each category if there was no correlation between the 2 variables. So even though this condition wasn't met, for the sake of the project, I continued with the calculations to show what I would have done if the condition had been met. But I have to understand that my results aren't reliable now. With the conditions done, I proceeded to plug my data into the formula for chi-squared, which is the sum of the expected value minus the observed value squared over the expected value for each category. The chi-squared value I got was 10.66. I have 4 degrees of freedom, which is found because I have 3 rows and 3 columns. So 1 less the number of rows times 1 less the number of columns is 2 times 2, which is 4. The probability of getting a chi-squared value of 10.66 with 4 degrees of freedom is my p-value, 0.03, or 3%. My test was conducted at the 95% significance level, which means that because my p-value is less than 0.05 or 5%, my data is statistically significant. I can reject the null hypothesis and conclude my alternate hypothesis, that there is a correlation between opinions of rain and perception of rain, at least within the student body of Ledyard High School. So in the beginning, I wasn't super excited about the statistics project, but in the end, it turned out to be pretty cool that through my statistics class, I learned enough to actually collect data in a sample and analyze it using real techniques. Plus, I learned that I'm 95% certain there is a correlation between students' preferences for rain and their perception of the rain, if we ignore that one unmet condition. Thank you.